everyone. Welcome back to another episode of Learn with Dr. G. That's me. Today, I'm really excited because we're continuing on our mini series around video game development. And today I have three amazing people who are going to talk about mixed reality. So stay tuned. All right, I am very, very excited, and I just want to jump right to it. So the first person that I'm going to have on this episode is April Speight, and she is here to tell us a little bit about mixed reality and design. April, do you want to introduce yourself?
Yeah, first and foremost, I was dancing to the music, so I like
same. Every time.
Yes. So hi, everyone. My name is April Speight. I'm a senior cloud advocate here at Microsoft on the spatial computing technology team. I've been working in mixed reality since last year, I want to say. So it's been definitely officially a year now, but I love it. And today I'm going to cover designing for mixed reality.
That's awesome. I'm very excited. Mixed reality has always been of interest to me. I've done a little bit of video game development, not a ton, but it just is such a black box to me. And so I'm so excited to have you here. And so you have some slides for us, right?
Yes, I do.
Awesome. All right, let's bring those up.
All right, is everybody ready?
Yes.
Get set. Let's go.
All right.
All right, so today we're going to cover the following areas. We're going to talk about comfort, scale, typography, color, light, and materials, sound, interaction models, and then I'm going to share some resources for those of you who want to read more about this once we're done today. Okay, so starting with comfort. If you've ever tried, let's say, a virtual reality experience, and you start to notice that at some point you start to get a little woozy, a lot of that has to do with our eyes. There's also some involvement with our feet too, but it has to do with our eyes and more so how our eyes function. So our eyes, when they are going to view an object, they accommodate, but then they also converge. So they accommodate to the distance of the object, and then they begin to rotate and converge to the distance of the object. So a really good example that we give, think of like a gnat, for example. If that gnat is just flying around and then it finally gets this close to your face, what's going to happen is that your eyes are going to accommodate to that focal distance, and then they're going to start to converge to that distance of the gnat to the point where they actually crisscross. But then when the gnat starts to fly away, our eyes become more parallel, and then we actually are able to view at optical affinity, and that's going to be at 6 meters. So that's more or less how our eyes actually function. You are like, what in the world?
No, that is so neat. It's the very first time I ever tried some virtual reality, anything. I think it was even an augmented reality. I was wearing glasses, and it just totally everything was just so wonky because I think it couldn't properly adjust in the way you were saying. That's so cool.
Yeah, and that's just something to keep in mind, even as like a user, because when you're even designing for like VR, for example, especially if you're doing like a stationary experience, your body's not moving, but your eyes are moving. And then when someone starts to move the camera around to so many different directions, you start to get a little sick from it. So keep that in mind as you're designing. You want to make sure that your users are comfortable as you create these experiences. Now, with regards to a really good, what we call the optimal zone, you're going to want to start at about 1.25 meters.
Okay.
And then out to about 5 meters. Anywhere between that is going to be a really good optimal viewing zone.
Yeah.
So super helpful. If you do that, your users will definitely be happy for it.
It kind of reminds me of like really old school games that were 3D but not 3D, and you kind of moved in this kind of weird way, but it feels like that was kind of the precursor to what you're talking about. Like it was trying to give you enough space to not feel like you were so jumpy.
Yeah.
I don't know. That's kind of cool. Awesome.
Yeah. Yep. So let's see. What do we have next? Scale. Okay. So what's really great about this area of technology is that we are finally able to display something at scale compared to some prior screen-based viewings, like our computers, for example. I'm going to use a car because that's more or less what I have here on the screen. So think about viewing a car on your computer. Sure, you might be able to get it at, a miniature scale of like of how big things might be if you're doing it to that kind of scale. But when you're actually viewing it through a device, you can actually create a full size car in front of the person.
Right.
So with that said, when you have objects in your scene, consider actually making them at scale. But there's a caveat to that. When you are adding them to the scene, you want to avoid starting the scene with the object like this close to the face. So like a car, for example, you don't want it to like be right directly in that person's line of view once they start, because they don't have an idea of just how big that object is. So instead, start with the object a little, well, not even a little, but a distance view in front of them, heading back to what we said about the optimal viewing zone. And then that gives the users a chance to adjust to understand how big the object is. And then if they want to do further inspection, they can get closer to the object.
Yeah. That makes a lot of sense. I feel like I've seen something similar with like smaller objects where they start them out at like a normal size, but like you said, just kind of with other reference points, and then you can kind of zoom into like a heart or something, and then you can make it big, but you don't want to start in like a random artery, right? Like
exactly. And I like to think of like if you were at a museum, for example, at least the ones where you can like kind of actually get a little closer to the exhibits, but you wouldn't want to start like right like this. You want to be back a little more, and then you can get closer to see what's going on up close. So that's scale. And then we have typography. So when it comes to typography, the one thing or the overall goal really is to make sure that it is clear as well as legible, because we want readers or users to be able to read what's happening in the experience. So when it comes to typography, you're going to want to stick with no more than 2 font families. If you start to add more fonts, it starts to get really distracting for the users, and they're not going to be able to consume that information as you think they will. Also with type, for any fonts that are going to be, or any text that's going to be 42 points or smaller, avoid thin lines, avoid the semi-light and light fonts, because what's going to happen is once they're in that experience, those thin lines actually start to vibrate. And then it's really difficult for the users to get a clear view of what it is that they're looking at. So instead, you're going to want to go with heavier font weights. 2 fonts that we suggest are going to be Helvetica as well as Arial, using those at regular, as well as the heavier fonts too. Another thing I want to point out about typography on the slide in this example, we actually do a really good job at this here, whereas we show hierarchy. So for example, if you look at Xenon, for example, we have the symbol up top, and that's going to be larger. And then we have the actual full name below, and it's going to be a little smaller in font. Same with in the far background where it says periodic table of elements, and then just below the GitHub link is a little smaller. It's like when you're writing a Word doc. If you're writing a document, all the font is typically not at the same like font size. So carry that over into working with mixed reality as well. And then one more thing about typography is color. I'm going to touch upon color in a second, but 2 good general rules of thumb. When it comes to working with white font, you need that to be against a more darker background. And if you're working with black font, that needs to be against a white background. And with black, and I'll get into it in a second, black is going to be transparent in your experiences. So that's why it needs to be aligned to a white background. And I know you're like, what? You can't see black?
I'm so curious now.
And I wonder if that's the next thing. So speaking of color, all right. When it comes to your immersive experiences, like your virtual reality, for example, colors are more likely going to display as you intend because it's more of like a 2D display, if you will. Whereas with holograms, we're looking at things now in a more 3D sort of way, the colors might not look how you intend. Right. That's going to be because when we show holograms in our mixed reality apps, they're created by adding light and then also light from the real world. So then with that said, white is going to appear very bright while black is going to be transparent. So with holographic displays, some colors will pop and some are actually going to be less impactful. And with that said, whatever you're creating, do try it out in the device before you have everyone go to use it, because the colors might not be what you intend. If you happen to walk around, well, definitely walk around, I would say, because I had an issue with an app I made where from one direction, it was beautiful. I could see everything. And then when I walked behind it, it was like nighttime, like you couldn't see a thing. So make sure you check that out. And so
I did not think about the fact that like the real world light needs to play a role.
Yeah. And you don't want it to be too bright. I ran into that problem too, because then I couldn't really see anything.
Yeah. Wow. When you were like, mixed reality design, I didn't think about all of these details. And I'm so excited to hear about them because it's just like any other, UX design, just more complex. There's like the depth and kind of the, heading size. And then there's like the light, but also the real world light. And that's so fascinating.
Yeah, it's definitely been a learning experience, I will say, for me. A lot of trial and error as well. But that's trying it out is very, very helpful.
Yeah.
The next thing I have is sound, which I believe is the last area before I head into the interaction models that we have. So with sound is actually going to be very helpful to either it's either going to be used to instruct some sort of action for the user, or it's going to be a way to reinforce interactions. Really good example, buttons. Let's say your experience has buttons that the user press to do some sort of action. Some sound should be associated with that, so that way the user knows this button press actually occurred. So when working with like the mixed reality toolkit, for example, and I'll talk about that in just a second, we have button prefabs that are already configured for Unity. And when you press it, we have a sound that actually plays to let you know that you've pressed the button. Same for, trying to think of another good example. We have an example of like a keyboard, an actual like not keyboard, but like piano keys. Like
neat. Yeah.
Down, you would think that you hear something. So it's like that. There was another example, but it's like slipping my mind right now. Oh, holographic keyboards. Yep. So typically you should have some sound when people type and not necessarily just silence.
Yeah.
But it's all to inform the user that, their sort of input actually, has been accounted for, if you will.
It reminds me of the very first kind of like iPhones where there weren't buttons. And I remember discussions around design there where you still wanted to feel like you were pushing
the
something.
Haptic touch. Yeah.
Yeah. And I like, this is so cool. Yeah. We talked about sound in the last episode on this mini series and just like how important. No, sorry, we're going to talk about it on the next one. I don't know. I'm all mixed up. We talked about how important sound is because it's not just, especially in video games, right? It's not just what you see and what you're interacting with, but when you've got the headphones on and you're immersed in a world, worlds have sounds, even in the silence.
Yeah,
right? There's the sound of silence, and that's just, this is so cool. Awesome.
Yeah.
So you said interactive stuff next. What do you have to share with us?
I do. So starting with interaction models. So one thing you want to keep in mind with interaction models, and that's going to be different ways you interact with objects. You should decide as the very first thing before you open up whatever your preferred platform is to decide how your users are going to interact with your experience, because the way they're going to interact will shape everything you build around it.
Right.
I'm going to start off with hand and motion controllers. So what you see, or what's here on the slide right now, is an articulated hand, which is a way you can simulate interactions in Unity with the Mixed Reality Toolkit. And it's grabbing this this cup. So in a real world situation, you're able to use your real hand and like, I can touch these shoes, for example.
Right.
This particular interaction model is going to be, has like the lowest learning curve for people who are new to trying anything out in mixed reality. And also you can use motion controllers. So whether that's like an Xbox controller or like with Oculus Quest, you have those sort of controllers.
Yeah.
That's going to be a motion controller. Now, a hands-free model is going to be using something such as voice, for example. And where this might be super helpful is if you created something where the user can't actually use their hands to interact. Really good example would be heading back to like that factory setting. If you have some sort of training app that shows a worker how to put pieces of a machine together, if they need to use objects in the real world to do it, you can't expect them to also use their hands to interact with the app. So using something like voice or speech commands, that would be a better choice for that. So do keep that in mind too.
That makes a lot of sense. Yeah.
Yeah. Yep. And this is also really good for people who might not be able to interact with like people who just can't hold, hold devices if they happen to be differently abled.
Yeah.
So being able to use speech is very helpful in that regard too. Gaze and commit is probably one of like the cooler ones to me, even though I love using hands, but gaze and commit's pretty cool. So what's happening on the slide right now is this particular example, it's focusing on an object and then it's also using a speech command. I recorded it from Unity, but when I say select, it like blows up. The hologram explodes. So with gaze and commit, there's two different types. I'm gonna cover the first one now, and then the next one will be the last thing we covered today. So for gaze, that's going to be, you have your head gaze, for example. So your head gaze is going to be whatever direction your head is facing. And then wherever your head is focused, for example, you can then do some sort of action to commit, whether that's doing a hand gesture, whether you're saying something, whether you're pushing a button on a controller. So that's with a head gaze and then commit. Now, alternatively, you have eye gaze. Eye gaze is almost similar, except for you're using your eyes to gaze. So what you're seeing on what's here on the slide, the blue box is moving up and down. I want to tell you what's going on though. In the actual example that we have within the Mixed Reality Toolkit, the focus right now, I'm moving it up and down because we're able to actually use eye tracking to scroll text as you're reading. So instead of you having to now go and move the cursor, we're able to do that for you. The text will program it for you, so that way the text moves up and down. Also really cool. 2 points I want to add before I head into the resources available for you. Eye gaze and working with speech. Get your user's permission before it's enabled. Because I will say definitely with eye gaze, I did a little bit of research into this. There's a lot of data you can pick up on a person by just their eyes. So you want to ensure that your users have given permission for your app to actually use that. And with also with eye gaze, you can only use it if the device has eye tracking. So if there's no eye tracking, there's no eye gaze. Likewise for speech, as long as you have some sort of microphone input and your users have permission, because people don't like being recorded without without being notified. So last thing I have here is just some resources. So we have way more information regarding mixed reality design by going to aka.ms/mr-design. And then Mixed Reality Toolkit, I mentioned it very briefly, but there are, it's a toolkit that I love. It helps accelerate your mixed reality development. You can go to those docs. This link will take you to the repo, which you can get the assets and the docs, and it's aka.ms/mrtk. Really briefly, let's see if I can pull it up.
Here, actually, I grabbed it for you.
Oh, yes. Perfect. Yes. Please check that out. And there's videos that are available as well. And then when you have a chance, Sarah, if you can switch back to my scene, there's one short little thing What we have right now on the screen in Unity is one of the examples that MRTK provides. We have a lot of example
That's
scenes
so
for you.
cool.
So definitely check that out. You can use them or play with them all within Unity. You don't need to have a device to try them out, but it gives you an idea to see how these different interaction models are. And we share more than just that too. So
that's amazing. So this is just the public GitHub repo with the link there on the screen. This is, gosh darn it. I thought I was going to have a relaxing weekend. This is so amazing. Oh, thank you so much, April. I really appreciate you coming on. If you do want to connect with April Speight over at Vogue and Code on Twitter, you can share with her and me your journeys into mixed reality and implementing some of these design tools. So thank you so much, April, for joining us. And
no problem.
Next, we do have another amazing developer who works in mixed reality. So I'm excited to bring on to the show Sarah Sexton. Hello, Sarah.
Hello. How is everybody doing? Oh, fantastic. And absolute kudos to April for such a marvelous presentation. I feel really honored. Thorough. Really, yeah. Oh, it's incredibly thorough. I feel really honored to share a platform where I get a chance to sort of talk about a concrete implementation of something that I worked on using and following those exact building blocks. So this is really lucky.
As if we planned it. I love it.
As if we planned it. So let me introduce myself first and foremost. Yeah, so my name is Sarah Sexton. Thank you so much for the opportunity to be here. I'm a software engineer at Microsoft. I work in the commercial software engineering department at Microsoft in Redmond. And I just love to have this chance to like highlight the strengths of mixed reality and using video game development as a chance to bring people in. One of my passions is bringing people of all walks of life into STEM. That's, science, technology, engineering, and math. And I love doing that through video games. I have a lot of technical focus areas, including artificial intelligence, game development, mobile app development, and web development, and many more.
Oh, cool.
And yeah, this is really cool. And I'm really excited for a chance to just sort of chat, paint a picture with my words about just, like there was this mixed reality game I built for Global Game Jam a while back. And
we learned about Game Jam. Sorry, real quick.
Go for it.
Gabby Ponce, who's a producer in Xbox in Turn 10 Studios, she was telling us a little bit about game jams and how they're kind of like hackathons, but for video game development, right?
That's exactly right.
So that's what this one was too. Was it like a full-on game jam?
Yeah. A game jam is a limited amount of time. So very similar to a hackathon where you basically have a chance to build an entire video game from scratch. So, you and all your friends who know how to do sound design or 3D modeling or game design, development, programming, you get a group of people together who can make a video game from scratch. And usually you have a weekend, like 36 to 48 hours to put one together from start to finish. So it's really chaotic and it's really fun.
Yeah, that sounds chaotic. But like you said, there are some principles that you can follow. And if you've done a few, and even if it's your first time, like that's the whole point, right? Trying and failing forward and seeing what worked and what didn't, and then doing another one later.
Yeah, and because they're almost addictive because they're so fun, and it's a great way for beginners who've never touched the stuff but kind of had that pipe dream where they always wanted to jump in and get their feet wet.
Yeah, it's actually it was actually a hackathon, but we kind of turned it into a game jam. When I was in school, there was a hackathon and we built a game, very basic Unity with just something in it. And then that was the precursor to what ended up being my entire dissertation for my PhD.
No way.
Where we ended up building a game to like teach kids to code. And it was like a 3D interactive game where you were a wizard and code was magic.
Get out of town. That
I literally just remembered that. Like the very first intro to Unity and to game development was a hackathon, aka a game jam. And yeah.
Oh, I love that. Cool. That is so cool. I love that so much. I want to hear your story and I want to hear more about April's story. I'm just going to take less time than you guys.
Well, you said that you built one, right? I totally cut you off because I got excited when you said game jam, and I'm like, I know what that is. But you said you built a game in a game jam. Can you tell us a little bit about it?
Well, it had the cheesiest name in the entire. I mean, like, get the bread and crackers ready because the cheese is real on this name. It was built for the HoloLens, and it was an augmented reality hide and seek game, and the name was Hello There.
I love it.
I'm ashamed to admit it was called.
Oh, I love it. I love it. Also, a HoloLens hide and seek game. That sounds like so much fun. Can you tell me more about it?
Yeah. So actually, I can break it down using the same building blocks that April just walked us through. So
awesome.
Yeah, like let's start with comfort.
Yeah.
So we were using the HoloLens 2, which, as I'll explain in a few minutes, it has both head tracking and eye tracking. And HoloLens 2 has a difference between the HoloLens 1. HoloLens 1 doesn't have eye tracking, so that's something that you need to account for. So with the comfort, it's kind of almost built into the HoloLens 2 because that's what they focused on when they upgraded from the 1 to the 2. They really hammered home comfort, and that's like physical comfort of how it like rests and where it puts the weight on your head physically, and also, as April was talking about, the like the resolution of the polygons that you're seeing. Like they make sure that the users have a comfortable experience because like they're using lasers and mirrors to show those polygons and like super advanced futuristic sounding technology. So like as a humble independent game developer at a game jam, we almost don't really need to worry about comfort because it's kind of built in. April may feel free to disagree, like, oh wait, actually no, you do need to worry about such and such.
I feel like you might be able to break it. Like if you tried, you could break out of comfort level or the comfort zone.
Oh yeah,
but absolutely. I think that's a really great point that like, I think game development sounds daunting, at least to me, because especially when I introduce mixed reality, because I'm like, oh gosh, I don't know how physics works in the real world, let alone in a video game. So how do I then integrate all of those pieces with the real world physics and the video game physics and like aesthetic and sound and all of that? But like you just said, the Unity and the HoloLens, like the tools that you have years and experts behind them to help you. And that just makes it a little bit easier to get started.
Yeah, don't let yourself be intimidated by the fact that, you don't have a degree in physics because there are tutorials and, building blocks that you could go to the asset store and buy 3D assets. Like, you don't have to program your own physics. You can, if you want to. Like, you can program the 3D vectors with the quaternions if you really want to, but you don't have to. You don't have to let that be a barrier to entry. You know what I mean?
Yep, that's a great point. Yeah. Although, getting some 3D assets off of the asset store, got to be a little careful. Ours, I didn't realize, had like blood all over them, and they were like these really scary gnomes. And we were like, hi, kids, want to learn how to code? And maybe not. Maybe a little bit more thought than what I did. But yeah, great point.
Good cautionary tale. Yeah. Yes, definitely. Yeah. So like watch out for things like that. Watch out, and like flashing lights might be bad for people with epilepsy. Be conscientious about all these kinds of things.
Yeah.
Have somebody, I guess that's a different kind of comfort, is like mental and emotional comfort.
Yeah. And actually, that's a great point. April mentioned, make sure that you ask permission from your users before you engage the eye tracking or the sound. And then you just mentioned, like if you've got flashing lights, you might want to have warnings. I think thinking about the accessibility and the inclusion of anything that you're building, and especially if you're building like an immersive experience, is just so important.
Yeah. I mean, I will advocate for that every day.
Yeah,
absolutely. So, and you don't want to creep your users out by like
having bloody gnomes.
Yeah, and tracking their eye movements without their knowledge. Yeah. So it's a brave new world. You want to be smart. You want to be conscientious and do right by your users all the time.
Yeah. So what has been either like your most exciting experience developing with mixed reality in games, or the most like challenging, and maybe they're the same thing? But I don't ever like to box it into one, just something where when someone says, tell me about your experience, you're like, oh, this one story, let me tell you about this.
Well, I mean, speaking of bloody gnomes and whatnot, I mean, I did do this project with a good friend of mine a while back where we used like a similar spirit to what was going on when Stranger Things had just hit the scene. So we had a mixed reality Demogorgon type monster creature, and it would like phase through a wall. And so what we did was we built that alphabet.
Yeah.
And we use the gaze and commit to like lock your gaze onto a letter of the alphabet. And it was the HoloLens 1, and you would air tap to select a letter. So you could spell words out on this alphabet by looking at the wall.
Right.
And then it would spell a word back to you, and it would say R-U-N. And you're like, run from what? And then the Demogorgon would just jump through the wall. Yeah, so we made a horror game with HoloLens. So that was my friend Kat Harris. We did that many years ago back on the HoloLens 1. Imagine how much more scary we could make it with like Stranger Things 2 and the HoloLens 2.
Oh my gosh. Oh my gosh. I'm just having so many ideas because I'm also now having ideas of like, could you also like string up some lights in the real world and have it be like connected to an IoT device. And so then as you're engaging, like the lights turn on in the real world.
Ooh.
And so then it becomes even more, oh gosh, I'm getting freaked out.
And that kind of brings us into what we were talking about when it comes to lighting and how lighting in the real world affects the holograms. Yes. That was definitely a challenge for us when we were working on that project, was getting the Christmas lights that were strung up to light up in a way that looked realistic, because holograms are made of light. And we may have already discussed that the fact that like the color black as a hologram doesn't work, because black just becomes invisible, because black is the absence of light. So when you're programming a horror game, you kind of have to use dark blue or something instead of black, because you don't have that as an option. And if you had like real life Christmas lights, that would also, it would throw off the lighting of your hologram. So you'd have to get really dynamic with that. That would definitely be a challenge.
That's true. Oh my gosh. There's just so many little aspects. That's why I love talking to folks who are way more expert than I am at these types of things, because there's so many little pieces that you don't necessarily think might be an issue. And what about like, whether you're playing the game in like outside or in daylight or at night or with the lights on or the lights off, or if you have those like smart lights that turn your room blue or something like that, like that just must be such a challenge.
That would be a really cool, the more immersive you can get, the better. And if you had like hue lights, that would be super cool. But again, it's like that same, like you almost have to program in Unity to have blue lights that go on at the exact same time as your real life blue lights. And it's
super so cool.
But everybody loves a challenge. As for wearing a HoloLens outside on a bright sunny day, you're going to come into that problem of like everything's going to look washed out.
Right.
You won't be able to see it as well because it's not really designed for that. Which is unfortunate, because I would love to have, you were talking about how you struggle with left and right. I do too. Yeah. And like, I need directions to get to places. I have a terrible sense of direction. I want like to have augmented reality in directions that have arrows, like just follow a giant arrow that tells me where to go. But if it was outdoors, it would get washed out by a bright sunny day. So we might be a little ways away from that, but I'm sure we're on the right track. Maybe if you can just use a regular phone for that.
There we go. I guess so. Yeah.
We're going to get there.
Cool, though. That is awesome.
Yeah. So I love what April was saying about scale, like a 1-to-1 scale. It's very intuitive. As long as you just remember like 1 meter in Unity is the same as 1 meter in the real world. When you're building a HoloLens application, you can use that. And so in this hide and seek game I was building Holo there, we were taking a page out of the book from Legend of Zelda Breath of the Wild, where you have the Korok seeds and there's a flower that blooms, and you can like follow these sparkly particle effects to find the flower, and it changes colors until you find a little like spirit of the forest who rewards you after you find it. So we were following like being inspired by that. So I was working with a 3D designer, and they did a model of a flower, like he built his own model. We used it as an asset in the game. And so we were really relying pretty heavily on color, light, and materials and sound, as well as interaction models. So everything April was just talking about. So especially like particle effects. And I wanted to talk a little bit about the use of spatial audio and spatial mapping and particle effects and that gaze implementation that we incorporated into this Game Jam game. There's another game that is a really good example of how to do this sort of stuff in mixed reality on the HoloLens. It's called Fragments. And so if you have a HoloLens 1 or 2, it usually comes in, installed with, or you can find it in the store, the Windows App Store. It's called Fragments. And what you do first in that game is you have to scan the room you're in, because it uses the room you're in the game. And so if you're playing real life hide and seek, we needed to use the room we were in real life in our game. So we had to use, so we had to use spatial mapping, and that puts this polygon mesh in the room around you. That's the one. That's exactly it. Yeah. Does it have screenshots of it?
I was looking for one. I didn't actually see the screenshots. I'll try to, here's a Fragments website. I'm sure they'll have screenshots on here. Oh no.
Womp womp.
Womp womp. I'll try to find some though. That sounds so cool. I love the interaction with what's real and then what's in the game, and that's so neat.
Yeah, so our game was super simple, like nowhere near as complex as Fragments. Fragments like has a plot and characters. Ours was just like, no way, you find a flower, it makes some noises, you're done, game over, you win. But sound was a really important element too. I just want to say, like where do you know where to look? Okay. I had another really good friend of mine give a talk about how she made 3D Fruit Ninja. Everybody loves that, from gosh, how many years ago? But like she described, my friend Adina Shanholtz described how could the user tell where the fruit was falling. And a lot of the time people don't look up. And she had this problem where the fruit was like falling and people couldn't find it because your view window is only so big. So you're like kind of like looking through a frame of where am I going to find something? You need to use context clues. You need to use sound, particle effects, these trailing effects. And so we used spatial audio with 3-dimensional sound, and we used these particle effects that would like direct your attention to where we wanted the user to look to find that flower so they could proceed to the next step.
That makes so much sense. Oh God, there's so many aspects to not just video games, but then, adding in the mixed reality part. And we have another person here too, who I think is going to tell us a little bit about her experience in developing games. So Sarah, do you have any kind of last minute, tips for those who are just getting started with mixed reality and or gaming?
Well, thank you so much for having me on the show. Follow these links to like Mixed Reality Toolkit and the docs. They will serve you well. And just like what April was saying about either instructing or reinforcing an action, like sound and particle effects and color. That's a great way to do that. You want to make sure that you're using all 5 senses. Well, maybe not taste. It depends on the game, but yeah, just engage the user. Yeah, thank you so much for having me.
I love that way of thinking about it. Well, thank you so much for joining us. Really appreciate it. And yes, so last but certainly not least, we have someone who I look up to in the space of mixed reality and gaming. We have Emilia Lazer-Walker here with us. Thank you so much for joining us.
Thank you. Except I don't know how I'm going to follow those 2 amazing presentations.
This has just been I just want to do like a 24-hour stream where we just chat and like show off things and try things. This has been so much fun already, and it's been like not even that long. But tell us a little bit about yourself. Can you introduce yourself?
Yeah. So I work on the same team as April. So I am also a senior cloud advocate on the spatial computing team. My background is more in game design and sort of specifically experimental games that use non-traditional interfaces and sort of new forms of technology, which is like naturally what led me to mixed reality. But it means I've done things with custom hardware, with sort of exciting machine learning. Like if it is new and exciting and no one's made a game out of it, that's what I'm all about.
I love it. I love it. I feel like that's one thing that I absolutely love about the side of video game development is like, how can you then bring it into the real world? Even if it's just the controller, right? It doesn't have to necessarily be like a physical or virtual reality thing, but like, what is that combination of the game that's on a screen and the real world. That is so cool.
Yeah. And so since we had like a nice a presentation with a slide deck and a nice informal chat, I sort of wanted to round us out and actually write some code live.
Yes.
So
I'm so excited.
We're going to be very ambitious.
Yes, let's do it.
So I sort of want to talk through sort of what I think of as my superpower as a game designer, which is using all of these sort of external APIs and sources of data and hardware. And one step further than saying we're going to build on top of Unity and we're going to buy some assets is how can we find some entire system in the world that already exists that we can just make that part of our game system and make that easier.
Right.
So I was really excited when the new Microsoft Flight Simulator came out this year, which yeah.
It is so exciting.
Yeah.
It is so exciting.
And for folks who don't know it, the reason this new one has taken off more than the last 20 years of serious flight simulators is the map is just a map of the real world, and you can fly in whatever the actual real weather is. You can literally go anywhere. You can go check out your favorite landmarks. You can go find your child at home. You can fly anywhere in the world, and it is a fully realized 3D space.
That is just absolutely incredible.
Yeah. So I want to build that in 10 minutes.
Let's do it. Let's do it. Do you want to share your screen?
Yeah, sure. Give me 1 second.
Oh, I'm so excited.
Is my screen live?
Yes.
Cool. So the way that they're actually doing it, the studio that made it is called ASOBO. They're a Microsoft-owned studio. They're doing a couple different things, and we obviously can't do all of them. But they're starting with a base of using Azure and Bing 3D maps data, where for a lot of places in the world, people have actually driven around and gotten 3D captured footage of cities.
Right.
For places where they don't have that data, they are using aerial satellite footage, and they're doing a lot of machine learning, and they're combining that with hand-authored assets and a bunch of really, really complicated things, which is why it took them years to release this game.
Right.
But the good news is all of this 3D map data that they're using as their baseline exists in API form, and we can just use it.
That is so neat. I don't think I realized that it was just available. I understood the impressiveness of the flight simulator, but to just have it there, that is just so neat.
Yeah, you'll see, it's not perfect. You're not going to be making a third-person action game where you're running around the streets of New York.
Of course.
But it's really good. And so they even have this really nice Unity SDK that we're going to use. If you already have an existing Unity project, you can add it using the Unity package manager. They have all sorts of different ways to set it up. But the simplest thing that I just did is if you download the repo, there is a sample project. And so I just opened the sample project fresh as it is in Unity. They have a whole bunch of examples you can pull up with a city tour and all this other stuff. We don't need to do that. Let's just make a new scene.
Yeah.
So what I really want to do is get it so we can drop ourselves in a single place.
Yep.
And then you can look around, and in a VR headset, we can look around and see the world in 3D. And then maybe rather than full flight simulator controls, I've got a flight stick. We're not going to wire that up right now. Just so if you press a button on your VR controller, you're going to move forward in whatever direction you're looking. So you can still explore a city.
Yeah.
So,
I love that. I love the fact that you're able to take something so complex like the flight simulator and really narrow it down and scope it to something that we can do in 10 minutes, right? Something that we can just build, and then you can always expand, right? But that is such an important part, I think.
And I think to me, if you're thinking about going to a game jam or something, doing something like this that you can get up and running really quickly, you now have this entire world of possibilities of what can you build on top of this once you have this base, and what game mechanics are implied by this. What would be fun to do, what fantasies exist in this world that is the real world,
which is the storytelling part of games, right? Just such a big aspect to it. Awesome. Okay, so you've got the sample project, and you created a new scene.
And so the two things the sample project does for us, the reason we didn't just make a new project ourselves, is it sets up mixed reality toolkit for us. So the instant we click play, it is going to come out of this VR headset that I have right here. It's going to have head tracking already wired up. It's already going to recognize input from these controllers.
Amazing.
That's going to save us a lot of time. And then they also pulled in the the Maps SDK, so we can just directly add it immediately and get going.
That is so amazing.
Yeah. So if we start, we can just add ourselves an empty game object.
Yep.
We can call it like Map Manager. Although we're not like, for something this quick, we're not necessarily going to follow Unity best practices. So don't take everything I'm saying as the thing to do. And we now have this beautiful map renderer component that if we zoom in on it, right now it's going to look pretty dead because we need to give it an API key.
Yep.
Unfortunately, there's supposed to be a way to copy it without revealing it, but it's broken. So don't worry, if you try to use this key, I will have already invalidated it, so you can't steal all my map data.
I have to do that quite often when I'm doing some Azure-related things on live streams.
Oh, yeah. So cool. We already now have this Unity component in 3D space that is showing us the entire world.
That's amazing.
I don't know if we exactly want it to be this big. So I was thinking we could focus on like the San Francisco ferry building, because that's like, we have nice, beautiful coastline.
Yes.
You can sort of see the sights of San Francisco. So I'm just copying that latitude and longitude. And we're just going to drop that directly into these boxes.
I also love that about Unity, that the components make it so much easier to interact with. So you're interacting with an API right now, right? But it's a part of a component. So it's just kind of, you just need to fill in that one box.
Yeah, we're not writing any code. They're like, filling in a box with a number is comforting and easy.
Yeah. This is awesome.
So this still looks like the whole world, but that's fine. We can increase our zoom level. Go all the way down.
Oh my gosh, that's so cool.
Take it like here, maybe. I think that was a good zoom level. I can't zoom out and see if we zoom out maybe a little more. Yeah, that's recognizably San Francisco. But we're gonna drop it in here. The only other thing we're gonna do is if I hit play right now, this is really tiny. Like we were talking earlier about how, like a single unit in Unity is a meter in the real world.
Right.
So this is currently a meter by a meter. So
right.
let's just make that a bit bigger rather than trying to make our camera smaller.
Right.
And then we're just going to bump this up so we get as much visibility in the world as possible. The only other thing we need to do before we can actually see anything cool is our camera now needs to be moved, because you can see from our camera preview, because this thing is now 20 meters tall, we're underneath it.
Right.
So if we move this, just zero it out. And then if we go to our main camera as well, we can move our main camera, Z at 0, and we'll say maybe like 12. We'll see how that looks, because like it's 20 tall, but that includes going
up buildings.
To the tallest building. Yeah.
Right.
And so we can tweak this. There's sort of a real sense of like how low you are to the ground just gives you a different subjective feeling.
Yeah.
Because I'm also assuming for now, like you could imagine giving people free 3-dimensional movement where they can move up and move down.
Right.
I think for simplicity's sake, for now, we're just going to say like
go forward and back. Yeah.
Yeah. But in theory, even with just this work, if we click play and I futz around with my headset a little bit, we should be able to see that.
Oh my gosh, that's so cool. Yeah. That was already so fast and just so neat. Oh my gosh.
This doesn't look like the ferry building, which means I copy pasted wrong.
but I can see the stadium, and that's just.
Yeah. That
is so neat.
Is that Chinese? I think we might be very wrong. Let's investigate this. Or actually, or we could not investigate it, and we could let ourselves move around and try to find where we actually are.
Yeah, based on like landmarks or something. That is amazing. That was so fast, just to be able to use that and have something just like amazing so quickly, right? And obviously, like all you're able to do right now is look, but like just the environment piece. I don't know if you've ever, folks watching, if you've ever built a video game in Unity, but like designing the world is just a huge, huge, huge part to it. And we built this tiny little world, and like just getting like the sloping right, and like, trees and stuff. And so just to have that was I'm just mind blown. That was so neat.
Yeah, I love this so much. And like the fact that, tons of money and tons of labor have already gone into this, and we can just like build on top of that rather than have to
Yes,
design a 3D space from scratch. Because like
exactly.
you're saying, even if we went and bought a bunch of really beautiful assets, we would still need to arrange them in the scene editor.
Yep.
So this is an amazing shortcut. And so from here, let's say we want to control our movement.
Yes.
I am going to cheat. Instead of typing this live, I'm just going to walk you through what I've already done, because this is literally 5 lines of code.
Yeah.
So, well, I guess take a step back conceptually. So what I want to do is, when you press a button on the controller, I want to figure out which direction you're facing,
Right.
and then move that. Because our Unity scene, like, we don't have infinite map in all directions, though. We have this relatively small square.
Yep.
We're going to do a classic time-old game dev tradition that predates 3D graphics, which is you're going to stay in place and the entire world is going to move underneath you like a treadmill.
Yes.
So like we have this with this map renderer component that we're using, we can set its center and it will automatically load in new map data, and it's going to do this quickly enough that it's going to be seamless for how quickly we're doing it.
Right.
Which is incredible. Like they provide all sorts of other APIs that we're not even touching to do things like animated tours where you're whooshing between city areas and adding in labels and doing all sorts of things.
That's so neat. Yeah, the first time I ever built like a platformer game, that was just such an aha moment of, oh, I don't need to build an infinite world where my little like character is just running through it. I just need to have like a world that can like repeat itself and have variance in the obstacles, and then that can just kind of like show, and it goes underneath the character. And I was like, that makes so much sense.
Yeah.
And so that's basically what you're doing here.
Yeah, and it's funny that like this still makes sense here, because if you go back, like if you're building an NES game, like to actually run on NES hardware, you have to do that. That is just the way your resources are limited.
Right.
That's the only way you're actually going to be able to like render stuff on a screen.
Right.
And even when you're moving up to infinitely more powerful computers and 3D graphics and pulling in all of this data directly from the cloud in real time,
you're still doing that.
That's still an effective strategy.
I love it. Yeah, so on update function gets called every so often, every iteration.
Yeah,
and then
Unity handles this automatically.
Right. And the fire one button, that's the trigger on the controller, right?
Yeah, this is, I think it is, it's one of the, it's like the top button on this,
nice.
On my specific Quest controller, it's the top one. This is all MRTK automatically mapping from the VR device to Unity's built-in input system that we're using here.
Right.
So like, even though we're not using all of the really fancy MRTK input stuff, we're still relying on them for this sort of basic automatic mapping we get for free.
That makes sense.
And then to get the camera heading, so, you know, the main camera is Euler angles transform. Like by default, rotation is just going to give us quaternions, and no one wants to deal with quaternions. He doesn't have a degree in math. And so the Y component specifically is going to be like this rotation.
Which way you're looking.
Yeah.
And all of these types of things, I've looked these up before when I've done it, because Euler, quaternion, like all of the math stuff, I don't necessarily want to be a stereotype, but like I struggle with those math concepts. And so there's so many docs on Unity on these pieces.
And like, to normalize this, like everyone struggles with this. Part of the reason I did this beforehand and
so
showing this code
confusing.
is because like I was reading all the documentation earlier, and like even once I realized that it was a quaternion, well, okay, there's Euler angles. There's also local Euler angles.
Yep.
In this specific code, it seems like the local frame of reference is identical to the world frame of reference, so it doesn't matter which I use.
Yes. Lots of little details. But the nice thing is that, you know, video game development, yes, there are some people who are going to be experts in these pieces of it. And they're going to be the folks who probably build some of the physics systems and like, you know, work to modify them and create, you know, slightly different ones. But those of us who want to just have a pretty generic, you know, walk around kind of experience, we can just use without like needing to go super deep into the details.
Yeah, this is why we use Unity.
Yep.
And then we're going to just need to convert it to radian. So this is giving us degrees, but then later on we're going to be using cosine and sine, and they're expecting radian. So this is the built-in Unity way to convert it, nice and easy.
Yep.
And so conceptually, all we're doing is once we grab our map component, get that map renderer off the same game object we're already on, which is part of why it's so nice to just have them be on the same game object for now.
Yes.
We can just set its center, which takes in, you know, latitude and longitude, and we can just take the existing latitude and longitude, take
Perfect.
sort of like a speed vector of, we know, you know,
Yep.
anecdotally from testing, this speed magic number is going to move us at a pretty good speed. Just multiply that by cosine and sine of our angle, and that means we're going to end up with a new location that is exactly this 0.00015 away,
Yep.
sort of in the direction of whichever way we were facing.
Yep. Makes perfect sense. And this is all C# code that you pulled up in Visual Studio Code, and Unity also pairs with Visual Studio. So whichever you're more comfortable with, you can jump into those.
I think sort of most power users tend to use Visual Studio if you're on PC.
Yep.
But I tend to use VS Code just because I switched between doing Unity on Windows and Mac, and it's really nice to have the same environment in both places. And so in theory, once we have that attached, in theory, if we click run again, and if Unity wants to behave.
That's always the question.
Okay, well, we have a different mouse cursor. Oh, is the headset? Oh, okay. This is a
There
good
it
sign.
goes. Yep.
We're thinking about it.
Click twice.
Oh,
It unplayed. There you go.
move my mouse away from there. So if I click it again, it's not going to do it. Okay. So here we are.
Yep.
Oh, Toronto. Okay.
Oh.
This is near where I live then in real life. But either way, if we move this way.
Oh, that's so awesome.
City streaming in. Oh yeah, I know where we are. If we go a bunch this way. Ooh, I think
what
the
a
speed
pretty
is a little
park.
faster than I intended. We're outpacing its speed a bit. Yeah, we got a lovely park.
That's so amazing.
Yeah, and like you can see, like the trees are a little clumpy. Like you really wouldn't want to be down at ground level, but this just works. Like
That's
you can tell,
so neat.
You can tell it's not fake since I didn't even intend for us to end up here.
Yeah.
I'll just have 3D data.
That is amazing. That is so neat. And we did it so quickly. And I guarantee you that I'm going to do this like right after this stream, because that was so cool. Well, thank you so much for helping us build like a playable game in minutes. That was so amazing. I'm definitely going to check out that toolkit and the SDK. Also the toolkit, but the Maps SDK. Any last minute words for any of our viewers on video game development or mixed reality integration?
Yeah, I think a big thing I want to hammer home is like this specific 3D Maps SDK is so cool and awesome, and you should use it. But I think to me that is less like this specific thing as much as this general approach of like go to a big company like Microsoft or some other tech provider and find what weird things are hiding in nooks and crannies that you can build games on. Like I've built entire games where the UI is a Google Maps widget rather than Unity. I've built games on SMS. I've built using like white label machine learning algorithms.
That's awesome.
If you lean on all of these other things, so many of like the engineering and design problems of game design just solve themselves, and it's such a fun approach.
I completely agree. Well, thank you so much, Emilia, for joining us. And that's pretty much what we have for today. Basically, you kind of heard the same things over and over again. And really, that's because video game development is about a lot of different aspects. The design is key, but the tools, the frameworks, the SDKs, the APIs, all of those things, integrate some of those tools and design into it, integrate some of those designs into the tools. And so even though design and the feel and the sound and everything like that, all of the 5, maybe 4 senses are really critical to think about, making sure that you're leveraging what other people, especially these big companies, are producing and using. It's important. You know, if you want to just get started, leverage what people have already made. And Yeah, that's basically what we have for today. As always, please feel free to reach out on Twitter at Dr. Guthels or hashtag Learn with Dr. G. And to see any of our other videos, you can head over to aka.ms/Learn with Dr. G. And until next time, I will see you all later. Bye.